Evaluate limits using graphs. Our first limit is limit of the absolute value of x minus 3 divided by x minus 3 as x approaches to 3. I gave you the graph. So let's take a look at the left limit. The left limit is, so we have limit as x approaches to 3 from the left of f of x. So what happened when x approaches to 3 from the left? We have a 3 right over here, right? So this is the left side, and then this is the right side. Okay, so as x approaches to 3 from the left, then we will be looking at this piece, right? So as x approaches to 3 from the left, y approaches to -1 the entire time. So the limit is equals to -1, and then as x approaches to 3 from the right, so we write a 3 plus, and then f of x, so we will be looking at this piece. So x approaches to 3 from the right, y is equals to, or I should say y approaches to 1, past 1. Do they equal? So these two, they are not equal, right? So they are not equal. Then what do we say? Then therefore, say that limit as x approaches to 3, whatever the function is, does not exist. We write d and e. We don't need to write the equal, just write d and e. That stands for does not exist. As long as the left and the right, they don't equal, then the limit does not exist. Okay, so let's take a look at the next one. The next one, we have 1 over x squared, right? So the graph is given, and then what happened when x is equals to 0? So when x is equals to 0, so this one basically x cannot be equal to 0, right? Because when x equals to 0, we have a what? We have a vertical asymptote. I will just write VA for short, vertical asymptote, when x is equals to 0. So let's take a look. X is equals to 0, we have a vertical asymptote right over there, and then this is the left side, and then that is the right hand side. So if you don't want to keep writing limit every single time, you can make it short like that. So x approaches to 0 from the left, and then the function approaches to what? The limit approaches to, is this a 0? 1 divided by 0, is that equal to 0? Of course not. 1 divided by 0 is undefined, right? So let's take a look at the graph. This piece, the left piece, as x approaches to 0, x is getting closer and closer to 0 from the left-hand side. What happened to the y value? The y goes all the way up. So that means the limit approaches to infinity, right? So as limit, past infinity, I would like to write a plus sign as well. What happened as x approaches to 0 from the right hand side? Y approaches to past infinity as well. But you might say, hey, then they are equal. Then the limit is defined, right? So overall, we say the limit as x approaches to 0, 1 over x squared. So this is just a past infinity. Whenever a limit equals to infinity, we say the limit does not exist. Okay. Let's take a look at the next graph. So the next graph, if we have limit as x approaches to 0, sine of 1 divided by x. This graph, I drew this graph using decimal, DESMOS. You can look it up on Google. It is a free graphing calculator. Okay, decimals. Here is the graph. So what happened when x approaches to 0 from the left? This is a pretty special example. So as x approaches to 0 from the left, as x approaches to 0 from the right, it looks like the point is right over here, right? It's right in the center, is 0. In fact, it is not right. So this one, as x approaches to 0 from the left or from the right, here is what we say. We say y oscillates between -1 and 1. What is that means? That means the graph looks like this, up and down is bouncing between -1 and 1, and we cannot decide what happened as x approaches to 0 from either side. So therefore, we say the limit as x approaches to 0 of whatever the function is, this one does not exist. Alright, so let's take a look at the last one. The last one, we have a piecewise function. F of x is equals to a linear function, -x plus 1, when x is less than 1. the function is equals to the natural logarithm ln x when x is greater than or equal to 1. So what happens when x approaches to 1 from the left? As x approaches to 1 from the left, we will be taking the first piece, right? So this is 1, we have a left side, and then we have a right side. So as x approaches to 1 from the left, we are taking the linear function, negative x plus 1, and then you plug in a 1. So we have a negative 1 plus 1 that is equals to 0. So y is equals to 0. And then as x approaches to 1 from the right, we will be taking the ln. So this is ln x. That is ln1. ln1 is equals to 0. So since this the left limit and the right limits, they are equal, we say limit as x approaches to 1, the entire piecewise function is just equals to 0 because the left limit is equals to the right limit. So it's pretty simple, and that's all for this part, and I will catch you all in the next lesson. Signing out.